Welcome to the Slop Temple. We pray this video helps.
In this video, I will explain how to connect Zero GPS. We will begin by exploring the fundamental components needed to establish a reliable GPS connection. This includes understanding the basic functions of a GPS module's pins and preparing your chosen microcontroller, such as an Arduino or Raspberry Pi, along with its power supply. Our goal is to equip you with the knowledge to successfully integrate a GPS module into your projects, enabling precise location tracking and data acquisition. Now, let's dive into the physical connections. Most GPS modules, like the popular Neo6M, feature 4 essential pins: VCC, GND, TX, and RX. You'll connect the VCC pin to your microcontroller's power output, typically 3.3 or 5 volts, and the GND pin to its ground. For data exchange, link the GPS module's TX pin to your microcontroller's RX pin and its RX pin to your microcontroller's TX pin, ensuring proper serial communication. With the hardware connected, it's time for the software. You'll need to install a library like TinyGPS++ in your Arduino IDE or similar environment. This library simplifies parsing the NME sentences transmitted by the GPS module. Your code will initialize a serial connection, typically at a baud rate of 9600, to read these data streams. Then, the library helps you easily extract crucial information like latitude, longitude, altitude, and precise time. Finally, let's test your setup. Open your serial monitor to observe the raw NME data or parsed information. If you're not getting a fix, ensure your antenna has a clear view of the sky. A cold start can take up to 15 minutes. Once working, your GPS module provides accurate location data, which can be used for diverse applications, from simple data logging to real-time tracking with compatible software or mobile applications.
Thanks for watching. Consider subscribing if we helped you.